Welcome back. This is third lecture of class 11th physics chapter 2 units and measurement. In this lecture we shall discuss errors in measurement. So let's start by understanding what are errors and the types of errors. Error is the amount of uncertainty in measurement of the magnitude of a physical quantity. So the amount of uncertainty or amount of inaccuracy in measurement of the physical quantity is called error. Now there are different types of errors depending upon the source. These are systematic errors, random error and least count error. So let's study about them one by one in detail. First, let's discuss systematic error. So systematic error can either be instrumental error, that is error due to faulty instrument, or it can be due to incorrect procedure, that is error due to wrong procedure or wrong practice. So sometimes, for example, if you are taking the temperature of a person, then we generally put the thermometer in the armpit. But this is not the exact body temperature of the person. It can be either 1 or 2 degrees more or less. So that's why such errors are called errors due to incorrect procedure, and they come under systematic errors. Now also systematic errors can be personal errors, that is the observer can be careless while observation. So sometimes if the person who is noting all the observations of the experiment, he notes it in incorrect way, then that can also lead to error. Second, random error. Now this is the error which occurs irregularly. It can be due to surrounding factors like change in temperature, pressure, etc., or due to the limitations of instrument. And the third and last type of error is least count error. The inability of instrument to measure quantities beyond the smallest value or least count is called least count error. So for example, if we take the example of the instrument vernier caliper. So vernier caliper has a least count of 0.01 centimeter. So it cannot measure values with the accuracy of greater than 0.01 centimeter. So if we try to measure a smaller value than that, then in that case it will give an error. Such errors are called least count errors. So this means that the instrument which we are using is not able to measure the quantities beyond its least count. Now let's discuss how do we calculate the error. So the first step in calculating the errors is taking the mean. We repeat the measurement multiple times and take the arithmetic mean to bring the measured value close to the actual one. So we take the measurements multiple times and take the arithmetic mean of all of them. So mean becomes A1 plus A2 plus A3 till AN upon N. This mean is treated as the true value. Now there are three methods to calculate the errors. First, absolute error. So absolute error equals to mod of mean minus measured value. Second, relative error. Relative error is equal to mean absolute error upon mean. And third, percentage error. Percentage error is equal to mean absolute error upon mean into 100. So now let's understand all these three things with the help of an example. So now let's solve a numerical. This numerical is from NCERT textbook. In this numerical, we have been given 5 values that are 2.63, 2.56, 2.42, 2.71 and 2.80 seconds. And these are the vibrations of a pendulum. So we have to find the absolute, relative and percentage errors in these values. So the first step to calculate these errors would be to find the mean. So therefore, we will find the mean. So mean is equal to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 seconds upon 5, because the formula of mean is sum of observations upon number of observations. So when we solve this, we will get that 13.12 upon 5. We've just taken the sum, and on simplifying this, we will get this equal to 2.62 seconds. Now, this is our final mean, and now using this, we have to calculate the errors. So first, let's find out the absolute error. So as you know, the formula of absolute error is mod of mean minus measured value. So therefore, absolute error will become, it will be different for different values. So for the first value, that's 2.63, it will become 2.62 minus 2.63. For the second value, it will become 2.62 minus 2.56. Or the third value, it will become 2.62 minus 2.42. Similarly, 2.62 minus 2.71 and 2.62 minus 2.80. Now we have to take the mod of all these values. So mod means that even if the value comes in negative, we have to consider it as positive. So therefore, 2.62 minus 2.63 will become minus 0.01, but as it is in mod, so therefore it will become plus 0.01. Similarly, this will become 0.06, this will become 0.20, this will become, again it will be in minus, but because it is in mod, so therefore it will be 0.09, and this will also become 0.18. So these are our absolute errors. Now we have to find the relative error. So for finding the relative error, the formula of relative error is mean absolute relative error is equal to mean of absolute values, upon mean. So therefore, first we will have to find the mean of these newly formed values, newly formed absolute error values. So therefore, the mean of these values will become 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 upon 5. So this is our mean absolute error. Mean absolute. So when we solve this, we will get that this is equal to 0.11. So therefore, our mean absolute error comes out to be 0.11. And now relative error is nothing but this mean absolute error divided by mean. So therefore, relative error will become 0.11 divided by the mean, that is 2.62. So therefore, this relative error comes out to be 0.11 divided by 2.62. And now we have to find the third thing, that is percentage error. So for percentage error, the formula is nothing but mean absolute error upon mean into 100. So basically what we have to do is nothing but take this relative error and multiply it by 100. Because this relative error is mean absolute error upon mean, so we just have to multiply it by 100 to get the percentage error. Now on solving this, we will get it equal to, roughly equal to, it will be something 4.1%, so we can write it as 4%. So therefore we have got all the three values. These are our absolute errors, this is our mean absolute error, this is our relative error and this is our percentage error. Now let's discuss another very important topic, that is combination of errors. So now the question arises that if we have an error in a value, then if we add it, subtract it, multiply it or do something in some operation on it, then what will be the amount of error in the new value? So consider that we have two numbers n1 and n2 and we add them. So basically n1 is 100 plus minus 10 and n2 is 40 plus minus 10. So 100 and 40 are the base values of the numbers and this is the amount of error which can be there. So either the number can be 100 or it can be something between 100 plus minus 10, 100 plus 10 and 100 minus 10. So it can be something between 90 if it is 100 minus 10 to 110 if it is 100 plus 10. So the number can be anything in between because it has an error in it. And similarly this n2 can be anything between 30, that is 40 minus 10, to 40 plus 10, that is 50. These are the ranges of number which we have. Now we have to find out then that when we add these numbers, then what will be the amount of error in that final result. So on adding n1 and n2, n1 plus n2, when we do that, then what will be the amount of error? We have to find that. So for this, let's take the worst case scenarios. So let's take that first we will add this 90 and 30. So first we will take the lower ends. So either we will get 120 and now if we add the upper ranges, then we will get 160. So this result will be something in between 120 and 160. Now if you observe it carefully, then you will get that this result can be anything in between 100 plus 40, that is 140, plus minus the sum of these absolute errors, 10 plus 10. So it can be anything between 140 plus minus 20. So if it is 140 plus 20, then it will become 160, and if it is 140 minus 20, then it will become 120. So here you can see that we got these values by observing it manually, and this is the formula, and by this formula also we are getting that the error, the final value will be in between these two values, that is 140 plus minus 20. Similarly, we can get a question based on subtraction. So on subtracting both these numbers, what will be the final result? So n1 minus n2. Now first we will observe them and see that what are the maximum range that is possible. So the maximum value that is possible is 110 minus 30. That is 80. And similarly, the least value that is possible is 90 minus 50. That is 40. So the result will be anything in between 80 and 40. Now let's see what is the formula for this. So the formula for this is, again we have to take the base values, but this time we have to subtract the base values. So we will do 100 minus 40. Then plus minus will come, and then we will add these absolute errors. So 10 plus 10. So in addition, we were adding the base values as well as adding the errors, amount of error. But in subtraction, we will be subtracting the base values, but again we will be adding the error. So the error, the amount of absolute error is always added, but the base value, it is subtracted when during subtraction, and it gets added during addition. So basically the final result will be 60 plus minus 20. So 60 minus 20 is 40 and 60 plus 20 is 80. So you can see that the result will be in between both of these numbers. Now we have to find the error in multiplication. So we are given a equation that A is equal to B into C, and we have to find that what will be the amount of error in this. So for finding the amount of error in product, we have to find the fractional change of them. So the error will become delta A upon A is equals to delta B upon B plus delta C upon C. So basically delta A means absolute error in A, and delta B means absolute error in B, and delta C means absolute error in C. And at the bottom the values will come. So this equation will represent the amount of error in that. Now we have to find the error in division. So here we are given an equation y is equal to A upon B, and we have to find the amount of error in this. So for this, again we will take the fractional change, that is delta y upon y is equals to delta A upon A plus delta B upon B. So again we will have to place the addition sign only between them. So again no subtraction sign will come, just addition sign will come. So it is somewhat similar to the multiplication method only. Now we have mixed addition, we have mixed multiplication and division, and also we have given powers. So let's see now how we will find that. So again the method will remain same. It will be delta y upon y is equals to delta A upon A plus delta B upon B plus delta C upon C. So again, if it is division or multiplication, it will be added only. But now one important change will take place. That is the amount of exponent that is there, it will get multiplied with that. So as there is A square here, so it will become 2 delta A upon A. And as there is nothing with B, so it will remain single. And as C is in cube, so that's why it will become 3 delta C upon C. So the final equation becomes delta y upon y is equal to 2 delta A upon A plus delta B upon B plus 3 delta C upon C. So the exponent is multiplied with the fractional value. So this was all for today. In the next lecture, we shall discuss about dimensions and dimensional analysis. Thank you.